My name is Elliot Salinas. I attend Wilmington University. I'm currently in cybersecurity and the research of the Internet of Things. I've been working on a project using Bluetooth Low Energy to create a heat map. The heat map is generated by several Raspberry Pis. I put them in this enclosure with a 3.5-inch display so they can be set up anywhere in different types of rooms. I use a keyboard handheld with a USB dongle so that I'm able to continuously use Bluetooth Low Energy even when they're connected. The objective is proximity using a beacon, these little eye tags that I have the MAC address to. The map is going to be created about 4 yards apart from each Raspberry Pi in a triangle format so that we're able to see location through the Received Signal Strength Indicator, or RSSI for short. The idea is to have 3 Raspberry Pis separated out about 4 yards apart. This will help us triangulate the location of the eye tag. That is the name of the beacon that we're going to be using in this project. Each individual Pi will be picking up that RSSI reading, and as it does that, it is going to filter out the outliers and create a median through a Python script that we call filter it. Once that median is taken out, it will then run it through a formula, which is this formula here. That will then give us the actual distance from each individual Raspberry Pi. Once that information has been created, it will upload it into the server. That server receives that information from all 3 Pis simultaneously, which will give us an accurate location of the device that we're looking for. Now, that being said, in a theoretical layout, such as a room that we already have the dimensions for, we can then get the accurate location of that device in the specific area that we're looking for. For the hardware, we started out with a Raspberry Pi 3. The reason being it having built-in Bluetooth made it a bit easier, less dongles that had to be used while in the project. Attached to that though, since that was just the base, we put it inside of an enclosure to keep it safe while in different environments. We attached a 3.5-inch touchscreen LCD. Now the only issue with that is because the screen was so small, we couldn't really run all the commands and open multiple terminal windows at the same time. So instead of trying to use touchscreen whatsoever, we decided to use one of these guys here, which is an RII8. Using a USB dongle, it was not connected through Bluetooth whatsoever, which made it accessible still for all the things that we wanted to do. It also has a touchpad so that we're able to navigate it completely as if it had a mouse attached to it. Less equipment, more versatility in that situation. And for the last part here, we just had a iTag, which we got off of Amazon for a couple dollars. Attached to it is just the MAC address, so we knew which one was which because of having so many of them. We were able to just kind of experiment and add it into the whitelist. So for the software, we're going to be using Raspbian Stretch on the Raspberry Pi. Included in that is going to be the terminal, which is already pre-installed, as well as Python 3. Inside of terminal, we're going to be installing BlueZ, so that we have the HCI tools that we're going to need. Mainly just 2, which is going to be LE-scan -- duplicate, which gives us a continuous reading of low energy scans, partnered with an HCI dump that is going to be piped into a Python script. Now the script's job is going to take the RSSI readings of the iBeacon. Now that we already have that MAC address logged into terminal, we're going to get that very quickly. With the Python script as well, we're going to be able to take out all the outliers of the RSSIs, and every 10 we're going to create a median out of that. That median is then going to be loaded into a log, which is then sent directly to the server. With the 3 Raspberry Pis working in conjunction with each other this way, the server is going to break down that information with a particular formula and run a separate script again. That script will then tell us an accurate proximity of the beacon that we're trying to track inside of the heat map. So as the project proceeded, we had set up everything with the Python script, with BlueZ, the HCI tools ready to run. Everything was accurate with the medians. We were in the process of setting up things with Flask, so that the Raspberry Pis could upload to a server, which would be on my Mac, and then to run that formula together to get those proper readings and get proximity. In the past weeks though, there was a talk done by Matthew Freilich, and we had the opportunity to sit down with him, my professor and I, and talk a little bit more about my project. we ended up finding some interesting difficulties that, as of right now, it seems like there is no solution for it just yet. Interesting enough is that wherever the Raspberry Pi is set up, the RSSI readings will always be completely different from how the room is structured together, with it either being metal studs or the material and the composites used in the walls themselves. If somebody was actually holding the beacon closed with their hand, the conductivity of a human being can also affect those RSSI readings. Other things that we found interesting is the fact that as the battery begins to decrease in capacity, the readings will also change as well. Some solutions we found for that: attaching a charger to it, something that gives it consistent power so that we can get more accurate readings. Further research on the topic, though, and the issues that I ran into, I soon discovered that many other people have as well. Recent studies and research done was attempted with using Wi-Fi, which failed and had the same difficulties as far as environmental issues, and even with using the magnetic filtering of devices themselves, like iOS. So at this point in time, it looks like the conclusion of this is that there is no solution for a heat map yet for proximity.